If you've been paying attention to the industrial automation space over the past few years, you might have heard the term Unified Namespace, or UNS, thrown around. And if you have, you've probably heard it a lot. Like, a lot. Almost like the incessant kick drum in a techno song. UNS. While a UNS can help your organization get in rhythm, in the context of musical metaphors, it's closer to a conductor, helping you orchestrate your entire enterprise except with data instead of music. Unified Namespace, a real-time single source of truth for data in an industrial or manufacturing environment, semantically organized like the business and built to be open. Open means that a UNS is not dependent on any one particular product. And that makes sense because a unified namespace needs to integrate multiple hardware and software solutions together if it's going to successfully standardize how an entire enterprise organizes and names data, not to mention codifying structures and events, all into one communication interface. There is no one-size-fits-all solution for building a UNS. Each organization establishes a UNS in a way that makes the most sense for their specific use case, but there are some commonalities every UNS likely includes. A software platform to manage the UNS. OT software for APIs, as well as device and network connections. Connections to smart sensors and PLCs, in addition to business and enterprise applications. A communication protocol to transfer data between the UNS database and its connections. And a central database or managed cloud data service. The data collected from this combination of solutions can be organized into an event-driven architecture, or EDA, that captures processes and responds to events from decoupled systems and publishes them in a time series order. At this point, you may be thinking to yourself, that sounds like a lot of work. Why bother? And how long is this video again? Well, you should bother because UNS is a modern improvement on the Purdue model, which ISA 95 based its standards upon. The Purdue model, to be fair, is over 30 years old. It had a good run, but a UNS more closely matches how organizations function and use data today. In contrast to the Purdue model, which relies on point-to-point communication between layers, a UNS consolidates this data transfer and extracts it from the traditionally segmented pyramid. This effectively sidesteps the need for specialized software engineering to establish communication between those layers. This gives you a top-down approach, with the UNS directing all communication between your SCADA, MES, ERP, and so on. Consolidating this data transfer creates a single source of truth, connecting all of your data to one standardized hub with context. A single source of truth reduces cost and complexity because you only need one communication interface and data type for read and write capabilities. It also increases both scalability and traceability, allowing you to directly integrate data consumers and producers by plugging them into a common network infrastructure. This enables any person, device, AI agent, or ML model to access data from anywhere in the organization in real time, making it easier to solve problems, perform predictive maintenance, derive advanced analytics, and streamline communication. A UNS can also enable the adoption of IIoT-enabled devices, which are essential for modernizing business operations, integrating cutting-edge solutions, and enhancing overall efficiency. The nice part is that this setup allows you to replace your system at your own pace, because IIoT gateways can publish data to the UNS on behalf of legacy devices that were designed for old-school point-to-point communication. You know, those devices that have been on your plant floor since the Purdue model was brand new? You know the ones I'm talking about. Establishing a UNS can be a sizable undertaking, but you can find everything you need within the Ignition technology ecosystem. Which isn't to say that this is the only way that you can create a UNS. It's just how we here at Inductive Automation would go about it. If you've made it this far into the video and you've never heard of Ignition, very briefly. Ignition is an enterprise industrial integration platform encompassing SCADA, HMI, MES, IIoT, and more. It comes with unlimited tags, clients, and designers. You can download a free trial in about 3 minutes and use it for as long as you'd like. Back to creating a UNS. The first thing you need is a communication method. MQTT is an IT-friendly protocol that uses an extremely lightweight publish and subscribe model to enable all of the components in a UNS to communicate from the edge to the cloud. MQTT was originally designed for remote sites in the oil and gas industry to communicate wirelessly and bidirectionally, optimizing network bandwidth with its pub-sub model. MQTT is reliable, efficient, secure, flexible, open source, and it decouples devices from applications, making it perfect for a UNS. Once you have your communication methods sorted, you need to create a model to give your data context before it reaches the UNS. Data modeling is the process of analyzing and defining different data types from your devices, creating a clear visual representation that explains connections between data points. If you skip this step, your data will just come from your devices raw and without context. No one wants that. For example, 12. 12 what? What does this mean? Without data modeling, we may never know. To create a data model in Ignition, you can use UDTs, which allow you to group tag information and essentially create parameterized data templates. A change to the type definition in a UDT is inherited by all instances, drastically saving time when making routine changes and enabling you to create nested directories that can be mapped into an MQTT topic structure. With UDTs, you can restructure data into a customized and standardized format with reference and derived tags as it's published to your UNS. One of the best ways to model data with MQTT is by using the open source software specification Sparkplug, which defines how MQTT is used by the UNS in a real-time environment, adds metadata about devices, and provides plug-and-play auto-discovery. In keeping with MQTT's low bandwidth protocol, Sparkplug reports by exception, meaning only relevant values are transmitted into the UNS database. Remember when I mentioned that MQTT was developed for remote sites? Well, remote sites are not known for having the most robust network coverage, so Sparkplug and MQTT have a store and forward buffer, meaning that in the event that your system does get disconnected, your data will backfill once your system reconnects. That kind of resiliency becomes pretty crucial when we're talking about enterprise-wide data usage. All right, so your device is producing data. You have your data modeled using UDTs. Now we need to look at actually transferring the data from the device to the UNS. This is accomplished through an intermediary server like an MQTT broker, which uses an access control list to first authenticate the device and then authorize whether it can read or write to a specific topic in the database. As a side note, it may be tempting to use this MQTT broker as a UNS, but that is not ideal, because data brokers are designed to keep data flowing, not store it. That store and forward buffer is pretty robust, but eventually you're going to want a long-term storage solution on-prem or in the cloud. Your data broker sends the modeled and contextualized data to a predetermined topic namespace within a UNS database or a data cloud service such as Snowflake, Sitewise, or ADT through an IoT bridge. Once the data is stored, you can interface with the database or cloud service through Ignition using SQL queries. And ta-da! Now you have actionable enterprise-wide data access. Before we finish up, we need to talk about cybersecurity. Having a UNS consolidating data from IIoT devices connected across the entire enterprise does pose a larger risk than multiple point-to-point connections using proprietary systems. Many organizations opt for setting up a DMZ to segment the business network from the plant floor network. In a manufacturing environment, a DMZ creates a buffer zone between two firewalls, like one at your PLC and one at the internet connection where your MQTT broker and its connections to the edge live. In addition to network segregation, we recommend you set up TLS encryption with MQTT in order to encrypt data throughout the network. However, you will need an SSL certificate from a certificate authority to enable this capability. You can find guides on setting up TLS in Ignition in the description below. Establishing a UNS is a substantial undertaking, but having access to actionable data is only going to become increasingly necessary to stay competitive and leverage technologies like AI and machine learning. The first step to building your UNS is to download Ignition if you haven't already, and check out Cirrus Link Solutions' MQTT modules for connecting to the edge and interfacing with data cloud platforms. And for further reading on Unified Namespaces, check out the description below. If you found this video helpful or you have ideas for topics you'd like to see us cover in the future, let us know in the comments. And while you're down there, like and subscribe.